Okay, so now we're going to do an example. We're asked to find the second approximation, x2, for this roots to this function, when this is function 0. And we're told we're going to start, our initial guess is going to be 2. Because that's kind of close to 0. When I plug in 2, we get 4 minus 3 is 1. It's kind of close to 0. So that's the idea here. In the last video, here's our formula for Newton's method. So our next x value, x1, is going to be x0 minus f evaluated at x0 divided by the derivative evaluated at x0. So we can see we've got our function. Let's calculate the derivative because we need that as part of the formula. Let me just do that over here. The derivative of f, well, the derivative of this is just 2x. So x1 is x0. We're told that x0 is 2. Minus f evaluated at 2 divided by the derivative evaluated at 2. Well, what is this? 2 minus f of 2. When I plug in 2 here, we get 4 minus 3 is 1. The derivative evaluated at 2. 2 times 2 is 4. 2, let's think of 2 as 8 over 4. Minus 1 over 4 is 7 over 4. And if you want to write that as a decimal, 7 over 4 is a 1 3/4, right? Which is 1.75. Okay, so that's our value for x1. Well, now what is x2? We'll use in our formula here. x2 is x1 minus f evaluated at x1 divided by the derivative evaluated at x1. Now we just plug it in. So what is our next approximation to the solution of this going to be? Well, it's going to be x1. We calculated that here. x1 is 1.75 minus f evaluated at 1.75 divided by the derivative evaluated at 1.75. So we get 1.75. When you plug it into your calculator, 1.75 squared minus 3. And when you plug that in, you're going to get about 0.0625. The derivative, if I double 1.75, we're going to get 3.5. Now again, just get out your calculator here, type in 1.75 minus that, and you're going to get 1.73. So this is the second approximation. It's x2. It's the second approximation using Newton's method for the solution to this equation. Notice just in the second approximation, look at the difference here. There's only 2/100ths of a difference. So this is telling us we're already, with just 2 iterations, we're getting pretty close to the solution to this equation.